Model-View Controller, or MVC for short, is a widely used design pattern for architecting software applications. Cocoa applications are centered around the Model-View Controller pattern, and many of Apple's frameworks make heavy use of Model-View Controller. Before we take a look at some of the problems surrounding MVC, I would like to make sure you understand what MVC is and how it works. As the name implies, the Model-View Controller pattern breaks an application up into three components or layers: the model, the view, and the controller. The model layer is responsible for the business logic of the application. It manages the application state. This also includes reading and writing data, persisting application state, and it may even include tasks related to data management, such as networking and data validation. The view layer has two important tasks: presenting data to the user and handling user interaction. A core principle of the MVC pattern is the view layer's ignorance with respect to the model layer. Views are dumb objects. They only know how to present data to the user. They do not know or understand what they are presenting. That is a very important aspect of the Model-View Controller pattern. The view and model layers are glued together by one or more controllers. In iOS applications, that glue is a view controller, an instance of the UI view controller class. A controller knows about the view layer as well as the model layer. This often results in tight coupling, making controllers the least reusable components of an application based on the Model-View Controller pattern. The view and model layers don't know about the controller. The controller owns the views and the models it interacts with. What are some of the advantages of the Model-View Controller pattern? In other words, what has made MVC so popular all these years? The most prominent advantage of the Model-View Controller pattern is a clear separation of concerns. Each layer of the MVC pattern is responsible for a clearly defined aspect of the application. In most applications, there is no confusion about what belongs in the view and model layer. What goes into controllers is often less clear. The result is that controllers are frequently used for everything that doesn't clearly belong in the view or model layer. While controllers are often not reusable, view and model objects are easy to reuse if designed well. If the MVC pattern is correctly implemented, the view and model layers should be composed of reusable components. If you spend any amount of time reading books or tutorials about iOS and macOS development, then you've probably come across people complaining about the MVC pattern. Why is that? What is wrong with the MVC pattern? A clear separation of concerns is great. It makes your life as a developer easier. Projects are easier to architect and structure. But that is only part of the story. A lot of the code you write does not belong in the view or the model layer. No problem. Dump it in the controller. Problem solved, right? Well, not really. Data formatting is a common task. Imagine that you are developing an invoicing application. Each invoice has a creation date. Depending on the locale of the user, the date of an invoice needs to be formatted differently. The creation date of an invoice is stored in the model layer, and the view displays the formatted date. That is obvious. But who is responsible for formatting the date? The model? Maybe. The view? Remember that the view should not need to understand what it is presenting to the user. But why should the model be responsible for a task that is related to the user interface? Wait a minute. What about our good old controller? Sure, dump it in the controller. After thousands of lines of code, you end up with a bunch of overweight controllers ready to burst and impossible to test. Okay, there are some problems with MVC, but how can we solve this? In recent years, another design pattern has been gaining traction in the Cocoa community. It is commonly referred to as the Model-View-ViewModel pattern, or MVVM for short. The origins of the MVVM pattern lead back to Microsoft, and it continues to be used in modern Windows development. The MVVM pattern introduces a fourth component, the view model. The view model is responsible for managing the model and funneling the model's data to the view via the controller. Let me show you what that looks like. Despite its name, the MVVM pattern includes 4 major components: the model, the view, the controller, and the view model. The implementation of a view model is usually straightforward. All it does is translate data from the model to values the view layer can display. The controller is no longer responsible for this ungrateful task. Because view models have a close relationship with the models they consume, they are considered more model than view. In the next lesson, we take a closer look at the internals of the Model-View-ViewModel pattern.